Question number 4, part A. Write 5 cos theta minus 2 sin theta in the form of r cos theta plus alpha, where r and alpha are constant. R is greater than 0 and alpha is greater than or equal to 0 and less than pi over 2. Give the exact value of r and give the value of alpha in the radian up to 3 decimal places. The equation is 5 cos theta minus 2 sin theta. This equation, if we compare with, that is r cos alpha cos theta minus r sin alpha sin theta. If you compare this equation, 5 is equal to r cos alpha and 2 is equal to r sin alpha. So r sin alpha is equal to 2 and r cos alpha is equal to 5. If we divide, we get 10 alpha is equal to 2 over 5. So alpha will be 10 inverse or arctan 5, 2 over 5. So that is 0.381 up to 3 places of decimal. Now suppose this is equation 1 and this is equation 2. So we square and add equation 1 and 2. So this is r square sin square alpha plus r square cos square alpha is equal to 2 square plus 5 square. R sin square alpha plus r cos square alpha will be r square. This will be 25 plus 4, 29. So r will be root 29. So this is the value of r. So alpha is 0.381 and r is root 29. So this is part 1. Now show that equation 5 cos 2x minus 3 cosec 2x is equal to 5 cos 2x minus 2 sin 2x. So let's say our equation is 5 cot 2x minus 3 cosec 2x is equal to 2. We have to convert it to sinus cos, so it will be 5. This will be cos over sine. Five cos 2x over sin x, sin 2x, minus 3 over sin 2x is equal to 2. This is sin 2x, so this is a common, we can multiply it here. So the remaining part will be, let's write it here, it will be 5 cos 2x minus 3 will be 2 sin 2x. So it will be 5 cos 2x minus 2 sin 2x is equal to 3, and it can also be written as c, where c is a positive constant. Now part hence or otherwise solve for x greater than or equal to 0 and less than pi. 5 cot 2x, this is the same equation, 5 cot 2x minus 3 cosec 2x is equal to 2. This equation can be written like this, and this is a c. C can be written any positive value, so instead of 3 we can write this is 2, so it has become now 3. So this equation become this. So now we have to simplify this. Now we are going to use first equation here. So our equation is, this is equal to r, what our question says is r cos theta plus alpha. So r cos theta is 2x plus alpha is 0.38, and in fact r, we have already calculated r. So r is equal to, we have r is equal to root 29. So this equation can be written in this form. So that is equal to 3. So cos 2x plus 0.38 is equal to 3 over root 29. So 2x plus 0.381 up to 3 places of decimal. So you can write it as arc cos 3 over root 29. So 2x is equal to arc cos 3 over root 29 is, so arc cos 3 over 29 root 29, or cos inverse 3 over root 29 is equal to 0.979923. 979923 plus, this is minus, it has changed the side, so it is minus 0.381. That is equal to 0.598923. 0.598923. So x is equal to 0.598923 divided by 2. So x is equal to 0.299. So up to 2 decimal places it will be 0.30, because it is from pi to 0. So we have one more value in the radian, that is 2.842 is there, so we'll write just this value. Question number 5, part A. The figure shows a sketch of part of a curve C with the equation y is equal to, the equation is y is equal to 2 ln 2x plus 5 minus 3x over 2, and x is greater than minus 2.5. The point P with the x coordinate minus 2. So this is minus 2 and this is minus 2.5. These are the coordinates. Find the equation of a normal to C. This is a tangent and this is a normal. Write your answer in the form of this. Now equation of tangent is y minus y1 is equal to minus dx over dy x minus x1. We have to find the equation of tangent at P, and we know this is x, so we have to find the value of y. So put x is equal to minus 2. So y will be 2 ln 2 multiply minus 2 plus 5 minus 3 multiply minus 2 over 2. So the y will be 2 ln 1 minus, this is 6, 3 times 2 is 6, 2 and 2 cancel, so it is plus 3. So that will be 0 plus 3, so y is 3. So the coordinate of P will be minus 2 and 3. Now to find the equation of a normal, we have got y1 and we have got x1. Now we have to find dy over dx. So why is this? So dy over dx will be 2. The differential of ln x is 1 over x, so 1 over 2x plus 5 multiplied the differential of 2x is 2 and 5 is 0 minus the differential of 3 over 2x is 3 over 2. So this is equal to 4 over 2x plus 5 minus 3 over 2. So at x is equal to minus 2, we have to find the dy over dx. So it will be at 2, dy over dx will be 4 over 2 minus 2 is minus 4 plus 5 minus 3 over 2. So that is equal to, this is 1. So 4 minus 3 over 2, that is 5 over 2. So that is the value of dy over dx. Now we put these values in this equation. So equation of normal at P, y minus y1 is 3 is equal to minus dx over dy is 2 over 5, x minus x1, x1 is negative 2, so it will be positive 2. So this is 5y minus 15, this is negative. So negative 2x, negative 4. So 2x plus 5y minus 15 plus 4 is minus 11 is equal to 0. So this is the equation of normal at P. The equation of normal at P. Now part B, show that the x coordinate of Q is the solution of the equation. It means we have to find the value of x. So our equation is y is equal to the Q is on the normal. So we better take the equation of normal. So that is 2x plus 5y minus 11 is equal to 0. So 2x plus 5, and the value of y is 2 ln 2x plus 5 minus 3x over 2 minus 11 is equal to 0. This is the value of y. So we have replaced this y by this equation. So 2x plus 10 ln 2x plus 5 minus 15x over 2 minus 11 is equal to 0. So we have 2x plus 10 times 2 is 20 ln 2x plus 10, this is 50. We don't solve it because we already have this 2x plus 5 in the answer. So what we are going to write is 10, we solve it this way, that is 2x minus 15x over 2 is equal to minus 10 ln 2x plus 5 plus 11. This is 4x minus 15x. So 11x minus 11x over 2 is equal to, we multiply to this side to make it simple. Minus 11x is equal to minus 20 ln 2x plus 5 plus 22. So x is equal to minus 20 ln 2x plus 5 over minus 11 and plus 22 over minus 11. So that is equal to 20 over 11 ln 2x plus 5 minus 2. So the value of x is this. Now part C is if x n plus 1 is equal to 20 over 11 ln 2xn plus 5 minus 2 and x1 is equal to 2. Find the value of x2. So you can simply put the value of this will be 20 over 11 ln, this is 4 plus 5 9 and minus 2. So you can get the value of x2 and you can get the value of x3. Question number 6. Given that a and b are the positive constants, on a separate diagrams sketch the graph with the equation y is equal to modulus of 2x minus a. So let's draw the graph of y is equal to 2x minus a. Let's take any value. Let's take it 3 is equal to 2x minus 3. So if x is 0, y is equal to 3. If x is 0, y is equal to minus 3. If x is 1, y is equal to 2 minus 3 minus 1. If y is 0, y is 0, x is 3 over 2. So the graph will be somehow like, so this is y is equal to 2x. Let's say it's any number. So this coordinate is a over 2 and 0. Now y is equal to positive value of 2x minus a. So this graph will now be, so where it is going to touch? So we can say this graph is so this is our graph where this coordinate touching x is a over 2 and 0, and the y coordinate will be a. Now the second part is y is equal to modulus 2x modulus 2x minus a plus b. Plus b means we have this now the graph is same, but it is y is increased by b. So this graph was here. Now let's have this b. So this is considered as a new axis. So the graph will be, and this is a over 2. So this will be the graph. So it will be a and b, and this will be a plus b. So these are the coordinates. Now let x is equal to 0. So this is 2 multiply 0 minus a plus b is equal to 3 over 2 multiply 0 plus 8. This is 0 minus a is minus a, is absolute value is a, plus b is equal to 8. That is the first relation between a and b. Now let's say x is equal to, c. So this is 2c minus a plus b is equal to 3 over 2c plus 8. So this is 2c minus a. Now this b can be written as 8 minus a. 2c minus, this is a. 8 can be written as 8 minus, so it will be 8 minus b. B is equal to 8 minus a. Is equal to 3 over 2c plus 8. 8 and 8 cancel. 3c, that is 2c, minus 3 over 2c is equal to 2a. So this is 4c minus 3c. So c over 2 is equal to 2a. So c will be 4a. Find c in terms of a. So this is c in terms of a. So that is the answer. Given that y is equal to 2x x square minus 1 is to the power 5. Find dy over dx. So that will be first function multiply differential of second is first function is 2x, differential of second is multiply 5 x square minus 1 to the power 4, and differential of x square is 2x. This is multiply plus x square minus 1 to the power 5 first function into differential of second is 2. So this is, we have x square minus 1 is to the power 4. So this is common. X square minus 1 power 4 is common. So we have 20x square plus power 4 is taken, so it's remaining 2x square minus 2. So that is, this will be 22x square. So this is 20x square plus 2x square, 22x square minus 2, and x square minus 1 is to the power 4. So we can say that gx is 22x square minus 2. Hence find the set of the values of x for which dy over dx is greater than or equal to 0. So dy over dx is greater than or equal to 0. This implies that x square minus 1 to the power 4 is greater than or equal to 0. It means x is, so x is root 1, so that is plus minus 1. And if 22x square is greater than or equal to 2, so this implies that x square is greater than 1 over 11. So x is greater than or equal to plus minus 1 over root 11. Now the next part is, part 2 is x is equal to ln sec to y, and y is 0 to pi over 4. Find dy over dx. Now here we can see that this is x. So dx over dy is equal to ln x is ln 1 over sec to y. The differential of sec is sec x tan x, and the differential of 2y is 2. This can be cancelled. Dx over dy, this is dy. So dx over dy is 2 tan 2y. So dy over dx is 2 over tan 2y. Now if we our equation is x is equal to ln sec 2y. So if we write it like this, so e to the power x is equal to sec 2y, and if we use the formula, we know that tan 2y is equal to sec square 2y minus 1. So that is e to the power 2x minus 1. So dy over dx will be 2 over root e to the power 2y. This is y. E to the power x. So e to the power 2x minus 1. So that will be the answer of dy over dx. Question number 8. The number of rabbits on an island is modeled by the equation p is equal to 100 e to the power minus 0.1 t divided by 1 plus 3 e to the power minus 0.9 t plus 40, where t is a real number and greater than 0. P is the number of rabbits. T is the year after they were introduced into the island. A sketch of the graph of the P against T, this is P and this is T, is given. Calculate the number of rabbits when they were introduced on the island. So when they introduced, so T must be 0. So P is equal to 1000, e to the power 0 is 1, divided by 1 plus 3 to the power 0 is 3 plus 40. So that is 100 over 4 is 25 plus 40. So P will be 65 rabbits were introduced. Part B is to find dp over dt. So that is 1 plus 3 e to the power minus 0.9 t square, and 1 plus 3 to the power 0 minus 0.9 t, multiply the differential of 100 e to the power. So this is, so it will be 100 multiply by minus 0.1 multiplied by e to the power minus 0.1 t minus 100 e to the power minus 0.1 t. the differential of this. So differential of 1 is 0 plus 9 times 3 is 2.7 e to the power minus 0.9 t. So that is the differential. So if I write it, so it will be equal to this will be 100 into minus 0.1 will be minus 10 e to the power minus 0.1 t plus 3 e to the power minus 0.9 t. This one minus 100 e to the power minus 0.1 t, and this will be minus 2.7 e to the power minus 0.9 t over 1 plus 3 e to the power minus 0.9 t square. So that is equal to this is equal to 0. For calculate the number of rabbits that were introduced on the island and find dp over dt. So that will be minus, let's take e to the power minus 0.1 t common, and this will be, let me make it a little shortcut here, so that will be negative 10 plus 240 e to the power minus 0.9 t. So that is equal to, so this implies that e to the power minus 0.9 t is equal to 10 over 240. That is 1 over 24. So e to the power 0.9 t is equal to 24. We have taken the reciprocal of both sides. So t will be 3.53. Now prove that sine 2x minus 10x is equivalent to 10x cos 2x. So sine 2x minus 10x. So sine 2x is 2 sin x cos x minus 10x is sin x over cos x. So if we take cos x as LCM, so this will be 2 sin x cos square x minus sin x. So we have taken sin x common. So this is 2 cos square x minus 1 over cos x. 2 cos square x minus 1 is cos 2x. So this is 10x and this is cos 2x. Given that x is not 90, x is not equal to 90, x is not equal to 270. Solve for x is from theta to 360. Sin 2x minus 10x. Sin 2x minus 10x is equal to 3 10x sin x. We have sin 2x minus 10x. We have just proved this is equal to, this one is 10x cos 2x. Minus 3 10x sin x is equal to 0. So 10x is common. We have cos 2x. Cos 2x can be written as 2 cos square x minus 1. So 2 cos square x minus 1 minus sin x. So this is 10x. 2, this is cos square is 1 minus sin square x minus 1 minus sin x. So this is 10x 2 minus 2 sin square x minus 1 minus sin x. So minus 10x, let me take minus outside. So we have 2 sin square x plus sin x, and 2 minus 1 is plus 1, so minus 1 is equal to 0. So now 10x is equal to 0. So x is tan inverse 0, and 2 sin square x, so if you solve it, that is a square 2a square minus a plus a minus 1, so that is a is 2, b is 1, and c is minus 1. So a will be, that is plus minus, this is 3a. So this is 3. So this is 3 minus 3. So that will be, it's 3 plus minus root 17 over 2. So this and tan inverse 3 plus minus root 17 over 2. So you will get 16.3, 163.7, 0 also, and 180 degree. So these are the values you are going to get. Thank you for watching. If any step is not clear to you, you can send me a text. Otherwise, don't forget to subscribe my channel. See you soon with another mathematics paper from Excel. Thank you.